Good afternoon. Today we would like to present our project to compile a web-scale Japanese corpus. This presentation is an overview of the NINJAL web Japanese corpus. This is a project to compile a web-scale Japanese corpus. The project goal is to compile a 10 billion word corpus of web text for linguistic research. The project began late in fiscal year 2011 and ended in 2015. We defined 4 requirements. The first is covering rarely occurring linguistic expressions. The second is ensuring balanced sampling over seasons and domains. The third is labeling word boundaries, morphological information, and syntactic dependency relations. The fourth is providing a search environment, including word boundaries, morphological information, and syntactic dependency structures. We published the NINJAL web Japanese corpus via the search system Bunten in March 2017. This is the table of contents of the presentation. Next, we present the design of the NINJAL web Japanese corpus. We will construct a 10 billion word web scale corpus. The corpus is based on the following 3 technologies. The first is page collection. We will show how to collect web pages. The second is linguistic annotation. This annotation is needed to allow linguistic research. We will present several issues in this regard: character normalization, word segmentation, morphological information annotation, and syntactic dependency parsing. The third issue is release. We will discuss how to make the corpus publicly available under copyright law. The first issue is that of page collection. We perform remote harvesting using bulk collection with the web crawler. We will present the web crawler on the next slide. Here we present alternative methods. Remote harvesting refers to collection using a web crawler or spider. Bulk processing means collection by a crawler using an automated search algorithm. For our project, we perform remote harvesting using a bulk collection approach. This slide presents how to perform it. We use the Heritrix crawler version 3.1. This tool was developed by the Internet Archive in the United States. The crawler is used by many national libraries, including the Japanese National Diet Library. Our crawling strategy is as follows. We crawl all types of Japanese web pages, including splogs, spam sites, and machine-generated pages. We crawl 100 million pages every 3 months as a fixed point observation. The target pages change each year. Next, we look at the linguistic annotation of our corpus. This is for linguistic research. We introduce 3 types of automatic processes. The first issue is text and character normalization. The collected web pages are in the HTML format. The HTML should be converted into text. In the conversion, we have to resolve character encoding issues. We use a toolkit developed by Mr. Yatta to help us do so. The toolkit is compatible with the Google Web Japanese Ngram method. In the normalization step, we extract Japanese sentences. These punctuations are regarded as the sentence boundaries. We split the text into the candidate Japanese sentences. Then, we excluded the following sentences. The sentences with less than 6 characters or more than 1023 characters are excluded. The strings with less than 5% hiragana transcription are excluded. The strings with less than 70% Japanese characters are also excluded. Even after such processing, the corpus is contaminated by some other foreign words. The second issue is word segmentation. Japanese text does not have overt word boundaries. Thus, we use Japanese morphological analyzers to obtain word boundaries and parts of speech. In Japan, there are several standards of word boundaries and parts of speech tag sets. The preferred word boundaries and parts of speech tag sets may vary by corpus user. We use the morphological analyzer MACAB and lexicon UNIDIC to create the various word boundaries and parts of speech annotations. The analyzer with the lexicon produces kokugo-ken short unit words with the UNIDIC part of speech tag set. The third issue is Japanese dependency analysis. We labeled bunsetsu boundaries and the bunsetsu-based syntactic dependency structure. There, the Kyoto Text Corpus Standard is a de facto standard in Japan. We use an analyzer called Kabocha. Next, we will talk about corpus release. How can corpus users obtain statistics or examples from the corpus? We prepare two types of release. The first is a web-based search application. The second is a word list with n-gram data. The web corpus has been released via an online service. We provide it as a web service called Bonten for a 25 billion scale corpus. The search application provides functionalities including string search with a keyword in context, quick view. It provides a corpus concordance system with word unit and parts of speech-based query, similar to the Chunagon system using BCCWJ. It also provides a corpus concordance system for a bunsetsu unit and syntactic dependency queries similar to the Chaki.net system. A tutorial video of Bonten will be provided in the future. The second form of release is offline. We released word lists and character word n-gram statistics. Word lists are with and without morphological information. The data can be downloaded from the following URL. Further, we provide pre-trained word-to-vec models, NWJC2vec. If you need NWJC2vec, please write to the following email address. Next, we would like to present data statistics of the NWJC. Next, we report our data statistics using statistics. The table shows the statistics of the pages collected from the fourth quarter of 2012, October through December, to the third quarter of 2013, July through September. Although we crawled 100 million URLs, we crawled only 60 million pages because of HTTP errors and the observance of the robots exclusion protocol, robot.txt. We performed duplication of the pages by checking hash values. The number of deduplicated pages is reduced to approximately 73%. Next, we would like to show the statistics of page changes in 4 quarters. Here, types of URLs refers to the unique number of collected URLs. Number of unmodified URLs denotes the number of URLs, the hash values of which remain unchanged within 4 crawls. Number of modified URLs denotes the number of URLs, the hash values of which are changed more than once within 4 crawls. 42.7% of the URLs are unmodified in 4 crawls. Page conflict refers to a case in which there are different URLs with the same hash value. This graph shows the statistics of page conflicts in the fourth quarter of 2012. The x-axis represents the number of conflicted pages, i.e., the number of different URLs with the same hash value. The y-axis represents the number of examples, which includes the number of conflicted pages on the x-axis. The graph is a log-log graph. The pages with fewer than 10 conflicts are copy pages or copy sites. Other pages are robots.txt or soft 404 pages, which report a not found error by returning a standard web page with a 200 OK response code. The table shows the statistics of the collected links from the fourth quarter of 2012 through the third quarter of 2013. We collected 7 billion links, tokens, and nearly 900 million links type from 100 million URLs crawled in 3 months. In 4 quarters, 1.6 billion links type were aggregated. The seed URLs of 100 million URLs increased 16 times in 1 year. The graph shows the statistics of incoming links in 2012, fourth quarter. The x-axis represents the number of incoming links from our seed URLs to the target link. The y-axis represents the number of examples, in which the number of incoming links is on the x-axis. The graph is a log-log graph. There are approximately 600 million links that have only one incoming link from the seed URLs. The most frequently linked incoming URLs are linked by 8.5 million pages. They are the top pages of popular blog hosting sites. The table shows basic statistics of the analyzed data. Because Heritrix outputs compressed 1 GB work files, the number of work files is approximately equal to the size in gigabytes of crawled and compressed data. The number of URLs is the same as in the preceding table. In the normalization step, sentence extraction detects Japanese sentences with boundaries. When sentence extraction is not performed, the morphologically analyzed data becomes 60 billion morphemes. On the other hand, when sentence extraction is performed, the morphologically analyzed data becomes 30 billion morphemes. This fact demonstrates that half of the text data is not in the Japanese language. Approximately 2.5 billion sentences, tokens, and 1 billion sentences, types, are extracted in the sentence extraction. Duplicated sentences are critical in corpus construction. The graph shows the statistics of sentence duplication in the fourth quarter of 2012. The x-axis represents the number of sentence duplications. The y-axis represents the number of cases in which the number of sentence duplications is shown on the x-axis. The graph is a log-log graph. Approximately 90% of 1 billion sentences appear only once in the corpus. 100 million other sentences appear more than once. The latter sentences are titles, anchor texts of links, or fixed phrases. The most frequently occurring sentence is shokugyo to kyaria, occupation and career, which is a category of Yahoo Answers. This part is the qualitative evaluation among our Corpora and Google Ngram. The highlighted parts are representative expressions in the titles, anchor text of links, and fixed expressions. The deduplicated sentence version of our corpus alleviates the issue of the fixed expressions. In the case of 5 gram or over, Google Ngram has the issue of the fixed expression. However, the deduplicated sentence version of our corpus is still robust for such expressions, even in 6 or 7 grams. This table shows the data statistics of the released version. We published fourth quarter data for 2014 with the following statistics. We provide 25 billion morphemes, tokens. Now, we would like to conclude this presentation. We presented an overview of the design of the web scale corpus at NINJAL. We are building a 10 billion scale web corpus. The corpus is constructed by means of page collection performed by remote harvesting. We will perform multi-layered linguistic analysis using several language analyzers. These will annotate word boundaries, morphological information, and syntactic dependency structure. The release media are twofold. First, we will launch a web-based concordance system with string search, word unit-based search, and syntactic dependency structure search, and register information navigation capability. We will also publish a word list and ngram. Thank you.